Hi everyone. I know since grade school, we've all heard of our senses, our top 5 being that of sight, smell, taste, hearing, and touch. And we use these to interpret our daily world, as well as many animals. There are also many different senses that we ourselves do not have, such as electroreception. Electroreception is the ability for an animal to detect electric fields and then respond based off of them. The animals that I will be talking about today are sharks. Sharks, along with rays and skates, are a group of elasmobranchs or cartilaginous fishes. And they are actually able to detect these electric fields very weak in the environment, mainly that of its prey, and able to attack and find its prey based off of this. This is an important sense for many sea creatures, for the fact that electric currents can move much more readily through water than it could through the air. These electric currents that they're able to decipher are called dipoles. Dipole is just an electric current in which there is a positive and negative side. So ions are what gives the positive and negative currents, and these are what the fish themselves can actually detect. So these sharks are able to detect extremely weak electric fields from its prey. These electric fields are involved in ion channels and myogenic, meaning heart, or action potentials involving movement. So this isn't the actual movement of the animal itself, it's these tiny little ions that are actually being produced from the fish or the prey in general as waste. They can leave the animal through its gills, through its mouth, through any open crevices within the animal itself. And these are tiny, extremely small electric charges. And the shark is most interesting in this aspect because they detect the weakest charge of any of the elasmobranchs. They can detect a charge as weak as 15,000 millionths of a volt. 1,000 millionth of a volt would be as if you said you have a AA battery and you create a gradient that starts in Long Island Sound and goes all the way to Jeffersonville, Florida, and you have a gradient across that area with just a AA battery, a shark would be able to determine within a few centimeters of this gradient whether this battery was turned off or on, and that's only 1,000 millionth of a volt. They are able to actually detect these changes by these special structures that align their face and the sides of their body. And these structures are called the ampullae of Lorenzini. They were discovered by an anatomist in 1678 named Stefano Lorenzini. And he actually found these structures when looking at the fish, and when opening it up, he found that these small holes along their face actually led to long crevices in which some were the same diameter as pasta. And at the end of these, they had these bulbous structures. And he had no idea what these were originally. It wasn't until the 1960s when they were able to find that the sharks were actually able to detect weak electrical fields within these structures. So how the heck does this work? It actually works because these small holes within their face have these long structures, these pores, that actually are able to take in the external environment. So the seawater can go directly within these pores, and at the end, the bulb is actually full of sensory cells. So these sensory cells can detect the tiny ion changes that are different from its internal environment versus the seawater or the external environment. And at the end of the bulb, with the sensory cells on one side with the pore, the sensory cell's opposite side actually has these neurons that send messages to the brain when these cells are excited. And this actually will allow the shark to create a behavioral change based off of this. It's very interesting as they have seen that the shark can actually is very accurate in determining where its prey is based off of this. So if I was a shark and a prey was to my right, it would emit tiny electrical field that would come into my right side pores, and that would tell the shark, hey, my prey is to the right. If my prey was extremely close, it would emit a stronger signal, so there would be more ions concentrated in the area, and I would be able to tell, hey, my prey is close to me and to my right. They're able to do this with extreme accuracy when they are within a few centimeters, because the ions themselves can dissociate or move away on long spaces, meaning they do need to be close to their prey. But usually they know that bottom dwellers, where they're looking, are close to the bottom. So if they are moving across the bottom of the water near the sand, they're usually able to find them and quickly dart and find them if they're hidden underneath the sand, in rocks, anywhere that they wouldn't be able to maybe see or smell them. This sense has actually been used for our own use for deterrence as a large electrical charge for scuba divers. So it's a non-lethal way for scuba divers to try to keep sharks away from them while they're swimming. What it consists of is a small pack that many people put on their ankles, and it has a long wire with that's 2.5 meters long, in which an electrode is on either end. And these two ends create a large electrical field that surround the diver, and when turned on, it has a large electrical current that deters the shark away, as it's not any electrical current that it would have within any of its actual prey. And they've actually seen this and documented it, in which the sharks move away extremely quickly when they're when they're in close proximity to the actual deterred area. And it has shown significant importance. It also is interesting to note that this has been studied within shark attacks. So say I was attacked by a shark and I am now currently bleeding, and somebody comes to save me. A shark is more likely to actually continue to attack me than the new person. And they believe this is actually not just due to the olfactory scent or the sense of smell of the shark. It's actually due to the fact that the blood that I would release has a higher salt concentration, and this actually increases the electric current capabilities of within the water, so the shark can actually feel my electric current much more strongly and would continue to attack me and display that behavior compared to attacking somebody who was saving me. This is interesting to note, as they've actually studied sharks compared to other elasmobranchs such as skates and rays, and they actually have found through looking at their types of breathing and comparing that to their actual response, they found that sharks have the exact same type of breathing throughout any type of signal that they're given, and that being a signal to attack. So no matter what the change in frequency that they were given, they had the same breathing rate to show that this was the breathing rate that they would have if they were looking to attack a prey, versus skates and rays. Actually, depending on the type of weak voltage that was given to them, they had different breathing rate responses, some being that of attack, but some being more subtle breathing rates that would be even lower, so a calming breathing rate, and some that were in the middle. And this actually showed that they actually use this sense for communication. Meanwhile, sharks seem to just use it for predation. It's interesting to note because it's one of the newer studies that was just published in 2018 that actually detect this. And they're looking into it further to see whether or not sharks are actually able to control this response, or if it's just an innate part of their nature. So overall, electroreception is an important sense for the shark. It's also important for other elasmobranchs. However, sharks seem to just use it for predation. Meanwhile, we are not able to detect any electrical charges. Thank you.